Okay, so what if I told you that you could teach an AI to master super complex tasks, not by letting it run wild in the messy, expensive real world, but by having it learn inside a perfectly controlled, synthesized dream? We're going to dive into this because researchers at Meta have built a framework that does exactly that. It's called DreamGym, and honestly, it might just change the game for how we build intelligent agents forever. But first, let's just frame the problem. Think about this. How do you actually teach an AI to use the internet? I mean, the whole internet, with all its quirks, without it accidentally deleting your account, buying 1,000 rubber ducks, or just getting stuck on a loading screen forever. And look, this isn't just a funny thought experiment. It's a massive roadblock for AI development right now. Yeah, that roadblock, it's so big, we can basically call it the AI training wall. It's this huge collection of fundamental challenges that makes training these powerful, autonomous AI agents incredibly difficult and, let's be real, just not practical. So let's break down this wall brick by brick. When you train an AI the old-fashioned way with something like reinforcement learning, basic trial and error, it costs a fortune and it's painfully slow. It's hard to find enough different things for it to do, the feedback it gets can be all over the place, and the technical setup is a total nightmare. Plus, and this is the big one, you can't just let your AI practice by, say, deleting items on a real shopping site, right? That's not a good look. So, to sum it up, the old way is expensive, slow, risky, and super limited. It's an approach that just doesn't scale. You're never going to build those amazing general-purpose agents we all envision with this method. It's kind of a dead end, which sets the stage perfectly for a totally new way of thinking. And that brings us to the big idea, the core of this whole thing, learning inside a dream. The name says it all, right? Instead of dealing with the real world, the AI interacts and learns in a completely simulated one, a world made of pure, synthesized experience. And this right here, this is the aha moment from the research. It turns out that AI doesn't need a perfect photorealistic copy of reality to learn. Nope. What it really needs is data that's varied, that's useful, and, this is crucial, that's causally grounded. In other words, actions just have to lead to logical, predictable consequences. That simple insight, that's the key that unlocks this whole new approach. And with that key insight, let's look at our comparison again. This new way isn't just a little bit better, it completely flips the script. It becomes affordable, fast, totally safe, and basically infinitely scalable. It solves every single one of the problems we just talked about. Okay, so how does this magic actually work? Well, welcome to the DreamGym. This is the framework that makes it all possible. Let's pop the hood and see how it runs. The core process is called experience synthesis. Now, instead of rendering a complex visual world like a video game, DreamGym does something way smarter. It creates the entire training experience using just text and reasoning. So the AI decides to do something, and the system just describes what would happen next. It simulates the outcome, the feedback, everything, all inside a language model. It's kind of brilliant. DreamGym really stands on three main pillars. First, you've got the Dream Engine. That's a language model that just figures out the logical consequences of the AI's actions. Second is the memory library, which I think is a great name. It's like the dream's subconscious. It's filled with real-world examples to keep the simulation grounded, and it learns from the AI's new experiences. And finally, there's the adaptive trainer. This is like the AI's personal coach, always creating new and harder challenges to make sure it's constantly learning and getting better. This all sounds amazing in theory, right? But the million-dollar question is, does it actually work in practice? Well, let's look at the data, because the researchers really put this thing through its paces in some seriously tough environments. The ultimate test was a benchmark called WebArena. Now, you gotta understand, this thing is a beast. It's so complex and so expensive to run that trying to train an AI on it the old way is pretty much impossible. This makes it the perfect showdown. Can learning in a dream actually beat learning in reality? And the results, honestly, they're stunning. As you can see here, the traditional methods barely even get off the ground on WebArena, with only about a 6% success rate. But the agents trained entirely inside DreamGym, they achieved more than double that. It's not even close. They succeeded where the old methods just completely failed. But this number right here might be the most mind-blowing stat of all. In other, simpler tests, DreamGym was able to match the performance of the very best traditional methods, and it did so using, get this, 0 real-world interactions. None. Zilch. All of its learning happened inside the simulation. I mean, wow. That just shows you the incredible power of synthetic data. So what's the big picture here? What does this all mean for the future of AI? This isn't just about finding a cheaper way to train models. It's about unlocking a fundamentally new and way more powerful way to build intelligence itself. And that leads us to what could be the killer app for this whole thing, a hybrid approach called Sim-to-Real, or S2R. The idea is brilliant in its simplicity. You start by training the AI in the safe, efficient DreamGym. It gets a comprehensive education, a powerful warm start, as they call it, before it ever has to interact with a real live system. And the results of this hybrid approach are just staggering. To reach top performance, traditional methods need 100% of their data from the real expensive world. But the DreamGym hybrid approach? It needs less than 10% of that real data, and it still achieves over a 40% performance boost. It's truly the best of both worlds, maximum performance with minimum cost and risk. So it turns out, just by rethinking the very environment where AI learns, we can overcome these fundamental barriers that have been holding the field back. And that leaves us with a pretty fascinating thought to end on, right? If an AI can learn this much, this efficiently, inside a world of pure imagination, what will it be capable of when it finally wakes up